Nation, glorious day here. Got my buddy again. Still talking about QC stuff. You know, last time we had to call in from the field about the slump issues. Hopefully, nope. Hold on, got something coming in. Kicking it out to our field guy. Apparently there's some air content issues.
Great.
Hey guys, I'm out here in the field. I was just informed that they rejected a truck because it showed up at 9% air and the specification is 5%.
If you've been in concrete QC for very long, then you know the difficulties of controlling air content.
So like 2 days.
Yeah, if you've been in concrete QC for 1 day, then most likely you have been made aware of how difficult it is to control air entrainment. First of all, just for those that may not know, cut that.
Nope, let it go. I don't know what the air is in concrete, but
Be very, very quiet. I'm hunting rabbits.
I know what air entrainment is.
Yes. Air entrainment is put into concrete for a very specific reason.
Intentionally put in versus entrapped air.
Versus entrapped air, correct. And that reason is, go for it.
For really cool stuff.
Yeah.
It's really for outdoor concrete, so you get more durability from water intrusion, freeze-thaw, things like that. It's really meant to let your concrete last longer. You don't use it in interior work for a variety of reasons, but you don't need it. So you only get entrapped air because indoors are always 95% is going to be AC controlled and heat controlled. So you're not really worried about the freeze-thaw on that. But the exterior concrete's really wanted at.
Sure. For the past 70 years or so, we've been putting air entraining agent intentionally into concrete to make little tiny air bubbles to do exactly what you were saying. Thank you. Thank you for that, Josh.
So for those who don't understand, and do not do this in concrete at your house, but like Dawn dishwashing, the little bubbles you see, that is the poor man's version of what that's happening inside concrete.
Yes. So as Josh said, please do not ever add a commercially available soap to concrete. But that's the idea behind it. The airs back in the day, in the late 1900s, as you've brought up in the past, were a natural resource that were really pretty forgiving. You had higher dosage rates back in the day, and the air entraining agent was a little more forgiving than today's synthetic air entrainment.
Right.
Today's synthetic air entrainment, you can run into some issues that we wanted to cover. And let's talk low air versus high air. So a truck may be rejected for both. But most of the time, many of the complaints that we got from the field was that our air was running high, so we would have to back it off. One of the first things I learned about the synthetic air entraining agents is that if you don't let that truck mix at the plant long enough, you can get a false low reading. Let's say I get 5% at the plant, but I didn't let the truck mix long enough.
Right.
It would appear to build air on the way to the job as it was being agitated. So you might get 5% at your plant, and all of a sudden you got 7.5%, 8% at the project. And that's something that can be a problem. So check with your admixture supplier, make sure that you're giving it enough mixing time before you take that plant check air
Mr. Brent,
job. Yes.
From a test man standpoint, if I've seen high air, I would let you know.
Yes.
And yes, there's specs, and I would let everybody know. But for the most part, there's a reason why high air can create issues.
Yes.
Low air was a completely different issue, and we'd definitely let you know there because of the durability issues of it.
Yes.
But of the high air content, low air content, which was the easier one to deal with?
The easier one to deal with was low air, because I could always hop in my truck and take some air entraining agent to a job site and raise that air content up. Once the air content is high, it's very difficult to adjust that back into a reasonable range without harming the concrete. So high air almost always was a rejection of the truck, and we really didn't have much choice but to dump the load. Now I know that there are some air detrainers out there, so if you've had experience using those and you like them, feel free to comment. I just never used them much when I was working in the concrete industry.
You didn't have the grate that just dropped all the air out of it and left the concrete.
No, there's no. And some people will tell you if you spin the drum up for 5 minutes, it'll pop the air bubble. Those kind of things I have found are not reliable.
Orange juice.
I have
heard
heard
orange,
yes,
orange juice
back in the day, man. Oh,
you know,
wow.
that might help, but you're adding sugars to concrete, which is not.
No, that's not a good thing. It's going to retard or cause the concrete to set slower. So there can be a lot of issues surrounding the air content, including things like with your high air. You can have issues that are also made worse by a mid-range or a high-range water reducer. Those products generally have the polycarboxylates generally have a defoaming agent because they know that those polycarboxylate water reducers are going to generate some air bubbles on their own. So one time, a long time ago, 20 years or so ago, we had a situation where one of the defoamer packages had separated from the water reducer. So we were pulling straight water reducer without the defoamer. We're getting 5% air on the pressure meter without adding any additional AEA on purpose. So check to make sure that, number one, you're letting the concrete mix long enough at the plant before you do your checks. Number two, that you're not getting some unintentional effects from your water reducers that are, if you're using a polycarboxylate. The third thing I wanted to mention was a situation that I heard about years ago on a project where there were trucks being rejected. We had a QC seminar or something, and the guy was telling a story where trucks were being rejected, and he had 5 or 6 trucks rejected from a project for high air, and they were running, according to the guy, 12 and 13% in entrained air, and that's really, really high for those of you that might not know. He went to the job, and when he got to the job, he's observing the tech who's running the air test, watches him run an air test, doesn't see any issues, runs his air pot side by side, and got 5.5% compared to the tech's 12 or 13%. Yeah. Then couldn't figure it out. Knows that a calibration of the pot's probably not to blame because there's very rarely one of those pressure meters get that far out of whack.
Right.
So the guy watched the process again, and during the cleanup, he noticed that the tech was cleaning his air pot out with something that was used to slick the lines in a pump truck. That one of the major ingredients was a detergent. So he's leaving soap in his air bubbles, and so in his air pot, so he was getting that reading on those soap air bubbles as well as the intentional entrained air. So a tech mistake can be one of the things that can happen. Hopefully not.
The testing company I worked for.
Yes.
Let me just be clear,
Yes.
that was not us.
Yeah. One other issue with so if you're running high air and the concrete is placed, sometimes that can cause something called air void clustering with the new synthetic airs. That's where the little air bubbles kind of cluster around the coarse aggregate particle and inhibit the bond of your coarse aggregate to your paste. So if you make it to the point where you can't explain why you've got these weird things going on, a petrographic analysis is the ultimate examination of that concrete to try to help you figure out what's going on. And there's plenty of labs in the country that can run those petrographic analysis that will help you.
Now, we talked about high air,
Yep.
true high air versus a user error high air, which that doesn't happen very often.
No, it doesn't.
That was a one-off case. But when you got low air,
Yes.
and you put it in there, you went and checked the batch weights, you did all the stuff, and the test man's going, nope, I'm supposed to have 4 to 6, I'm only getting 2.5. You test it, and you're still getting the 2.5.
Yes.
Where do you start looking at?
All right, so there's really 3 things that are contributors to low air. 3 main things, there's probably more, but the first thing that I would want to check is some of the supplementary cementitious materials like fly ash are going to have carbon in them as part of the process that they're burned.
Right.
You know, they're burning that coal, or they're processing another SCM in some way. That carbon content is reflected in a measurement known as loss on ignition, or LOI. And they're required to report the LOI on the mill certification. As the LOI creeps up on those fly ashes and some other materials, the air entraining agent will lose effectiveness. Those little carbon, the way it was explained to me, and I don't know if it's technically correct, so if you know the answer, please comment. The way it was explained to me is that those little pieces of carbon pop the air bubbles or absorb some of the air entraining agent itself and can cause big problems. So if you got a LOI above 4%, it's really difficult to deal with when you're trying to put air in the concrete. Next thing is fines in the aggregate, specifically crushed fines. So if you've got a crushed rock or crushed manufactured sand, those crushed particles, 57 below, can be really angular and pointy. And so sometimes it is more difficult to entrain air when you have fines that are angular and pointy, because they're going to want to pop those little bubbles. And that's kind of the way it was explained to me. But then the last thing is going to be concrete temperatures. When your concrete temps go up, your air entraining agent generally loses some effectiveness. So you might be running 1.5 times the amount of air entraining agent in the summertime as you are in the wintertime. So those are the three main things. You probably run into others. If you have, let us know. But air content is very important for concrete. And if you get out of whack either direction, if you're low air and you do a job that's got low air, durability is going to be affected. If you have a job where they actually place high air concrete, strength can be affected, as well as the durability of the surface and other things. So it's always good to try to stay in that range of air content that you're looking for. And these are some tips and pointers to help you stay there. Hope it helps you out. Yeah,
Seriously, with all the stuff you're killing about pointers.
Pointers, you like that?
Yeah.
Yeah.
That wasn't intentional.
No, it wasn't. Sometimes I make jokes accidentally. Thank you so much for watching this video, and I hope it helped you out some. Comment, like, subscribe, and we'll see you next time when we discuss yield complaints.